In this lesson, we'll be talking about how do we find extrema when we're given a graph. So extrema are the maximum and minimum values of a function. Extrema can be considered absolute, and another term for that is global, or it can be considered relative, which is another term for that is local. So absolute and global extrema mean the same thing. Relative and local extrema mean the same thing. And we'll talk about in this lesson what the difference between those are. In this lesson, we're also discussing the extreme value theorem. So it says if a function f of x is continuous over the closed interval a to b, then f of x has at least one minimum and one maximum value on a to b. All right, let's talk about the different types of extrema. So absolute or global extrema is the highest or lowest y values on the function's graph. Whereas relative or local extrema are y values of a function where the function changes from increasing to decreasing or vice versa. And sometimes it helps to make sense of that by actually looking at a graph here. So if we look, we have a piecewise graph, and we're going to find absolute and relative extrema here. So if we look at this first bullet point, it says the function has an absolute maximum of blank at blank. That's how we're always going to write extrema. We're always going to say maximum is referring to the highest value or the lowest value, which is a y coordinate. Okay? But it occurs at an x value, an x coordinate. So we're going to always write maximum of something at something, fill in those blanks. So the function has an absolute maximum of the very highest point on this graph is over here. So I'm going to say that it has an absolute maximum of 9 at x equals 3. When we look for the lowest point on the entire graph, we can see that over here. And that is where we have our absolute minimum. So when we write that out, we're going to say the function has an absolute minimum of -7, and it occurs at x equals -1. But now let's talk about relative extrema. So the function has a relative max of something at something. So a relative max means related to the points around it. So if I take a look on my graph here, I'm going to highlight in blue at this point here, that is higher than the points to the left of it and the points to the right of it. So that is what we consider a relative max. So we're going to say that the relative max is 3, and it occurs at x equals -6. When we look at relative min, and I'll write for this one here, relative max on the graph. When we look at relative minima in this picture, we have 2 that are given to us. So I'm going to highlight these in green. If I look at this point here, that is a relative minimum. And I also have another relative minimum over here. So this happens that the absolute minimum and a relative minimum can be the same value. Okay. The very lowest point on the graph can also be lower than the points around it. So an absolute extrema can also be considered relative. So let's fill that in here. The first one we identified was the relative minimum of -5 that occurred at x equals -7. And then we said that the absolute minimum from before can also be considered a relative minimum. So we're going to fill in that information from before again. So that's -7, and that occurs at x equals -1. Just an important note, and we'll be talking about this in subsequent lessons too, absolute extrema can occur at an endpoint, but relative extrema cannot. All types of extrema can occur within an open interval. It's important to note here, the little asterisk, that some textbooks and curriculums may define this a little bit differently, but in all of my videos here and in my notes, we're going to go with this idea that absolute extrema can occur in an endpoint, relative extrema cannot. That's because we cannot compare the points to the left or right of it. So like for instance, if I take a look at this point here, I cannot consider that a relative extrema because I have no idea what's happening to the left of it. I cannot relate to the points to the left. So we can consider endpoints absolute extrema, just not relative. Let's take a look at some other examples here. So on this next page, we're given a bunch of graphs, and we're going to find all absolute and relative extrema. When I take a look at number 1, this one does not have much going on, but we can see that we definitely have a minimum over here. So I'm going to say that this is an absolute, I'm going to be abbreviating here, minimum of 0 that occurs at x equals 3. Just note that we can also consider this a relative minimum because related to the points around it, it is lower. Okay, let's take a look at number 2. If we take a look at number 2, we have a parabola here. We have a quadratic function. We could see at that point here that the derivative is 0, and that's what creates that maximum value. So an absolute max of 0 occurs at x equals 0 for this graph. For this, I'm just going to put a little asterisk and note next to this that you could also consider this relative. So for on the remainder of the problems, if the absolute minima can be considered relative, I'm just going to put a little asterisk. So we can even go back to number 1 and note that too. So I'll be putting that mark for each time that would apply. All right, for number 3, we have a piecewise function here. If I look at number 3, the absolute minimum occurs at -1. Excuse me, absolute minimum of -1 occurs at x equals 9. But we also have another minimum on the graph. We also have this one at x equals -1, and that y value is 1. So we have a relative minimum of 1 at x equals -1. This graph does not have any maximum that we can identify. We do not have an absolute maximum because we see this arrow over here. That's telling us that we are going up to infinity, so we cannot find the highest value of this function. Okay, number 4, another piecewise. So if I take a look at this, I have an absolute maximum of 3 that occurs at x equals 0. Just going to note there that we can also consider that relative. And we have an absolute minimum of -2 that occurs at x equals +2. And again, that one can also be considered a relative min. All right, for our last one here, we have quite a large piecewise graph. So if we take a look at this here, again, I'm going to be putting those little asterisks for when the absolute can also be considered a relative. So let's start with the absolute mins and maxes of this graph. So we have an absolute minimum of -9 that occurs at x equals -9. Okay, so that's over here on the graph. And I have an absolute maximum over here. So an absolute max of 4 at x equals 5. That is an example of one that can be considered relative as well, related to the points around it. Compared to the points around it, it is higher. So we can also consider that a relative max. Now, there are a lot of ups and downs in this graph if we look especially at the middle. So there are a bunch of relative minimum and maximum that we can also identify. So let's go through them. So I have a relative max of 1 at x equals -2. So that's this point here that I'm bolding. And then let's just go to the right a little bit. Over here, now I have a relative minimum. So that would be a relative minimum of -2 at x equals -1. Move a little bit to the right on the graph, and I have another relative max. So a relative max of 1 at x equals 0. Move a little bit to the right on the graph again. And I have a relative min of -2 at x equals 1. And now we have accounted for all of the extrema on this graph. In future lessons, you'll be learning how do we find extrema when we are just given a function and we do not have a graph to look at.